Hi there. Welcome back to the wild world of sediments and sedimentary rocks. This is part 6. You should have already reviewed parts 1 through 5. In part 6, we will talk about sedimentary rocks per se. We have already talked about the creation of sediment, the erosion transportation, the deposition, and the process of lithification, or the transformation of sediment into sedimentary rocks. So we will concentrate on sedimentary rocks now, the clastic versus the non-clastics. On the picture, I'm standing by a very massive limestone member within the Glen Rose Formation in central Texas. In terms of the rock cycle, we have already covered the areas that are highlighted in red. The last area for us to cover is the one that is circled, sedimentary rocks. So what is the official definition of a sedimentary rock? Well, it's a rock that forms from compaction and cementation of individual grains or from precipitation from chemical solutions. We classify sedimentary rocks as clastic versus non-clastic. The picture, some sedimentary units in the Grand Canyon area of Arizona. When we talk about sedimentary rocks or sedimentary layers, we typically refer to the layer cake geology. Remember that we talked about the principles of initial horizontality and superposition in one of our previous discussions. Well, this is a great example on this picture here. The sedimentary layers are laid down pretty much in a horizontal position, and superposition tells you that the oldest layer is on the bottom, the youngest layer is going to be on top. This bedded sandstone that is found in Arizona is a classic, beautiful example of what we would refer to as layer cake geology. Remember, we classify sedimentary rocks as clastic or non-clastic. So which ones are the clastic sedimentary rocks? Well, examples will include conglomerates, breccias, sandstones, siltstones, and shales. Let's look at each one of these. The outcrop on the picture is a sandstone outcrop in the North Texas area. Conglomerates are rocks that consist of rounded pebbles that have been cemented together. In contrast, breccias consists of pebble-sized to cobble-sized rock fragments with angular edges that have been cemented together. Pebbles in a conglomerate indicate transportation over long distances. If you recall our previous discussion of rounding, in one of our former sections, the longer the transportation distance, the more time these larger particles have to become well-rounded. Pebbles or cobbles in a breccia indicate proximity to the source or a short distance of transport. Remember, these are angular particles. As far as the pictures go, the one on top is a classic conglomerate with well-rounded particles that have been cemented together. This conglomerate is found in Texas. Picture on the bottom is a breccia with angular fragments, both cobble size and pebble size, that have been well cemented together. This breccia is from Colorado. Sandstones are sand-sized particles that have been cemented together. Siltstones are silt-sized particles that have been compacted and cemented together. And shales are clay-sized particles that have been compressed or compacted together, possibly cemented. The pictures clockwise from the top left, we have a sandstone uh, from the Garden of the Gods in Colorado. Next to it is a picture of a siltstone in the North Texas area. And the picture on the bottom is a shale that has within it a light color layer, which is a bentonite seam. Bentonites are clays that are derived from the alteration of volcanic ash. And what about the non-clastic sedimentary rocks? Well, examples include halite or rock salt, uh, NaCl or sodium chloride, gypsum, which is calcium sulfate with water in its chemical formula. That is the CaSO4 times 2H2O. Anhydrite, which is calcium sulfate without water in its chemical formula. Limestone, which is calcium carbonate, or the CaCO3. Dolomite, which is a calcium magnesium carbonate. That's the CaMgCO3. And we have also chert and flint, which is microcrystalline quartz, silicon dioxide or SiO2. Chert is generally light in color and flint is dark in color. The picture is a massive limestone within the Glen Rose Formation in Texas. And I will conclude this section now showing you two pictures. One is a classic gypsum rose shown on the left. Again, remember this is calcium sulfate with water in its chemical formula. And the other one, I'm standing on this massive limestone along the Biloxi River in the town of Glen Rose in Texas. That's it. That's part 6. So we have one more part to go, part 7. So see you then.